Good morning. In this video lesson, and today we're going to continue to focus on solving equations that have fractions involved in them. Our objectives today are the same as yesterday. Our big focus is to understand that when the equations involve fractions or decimals, we're going to be using the same process we use to solve equations. The big thing is we'll just have to remember how to work with addition, subtraction, multiplication, and division when we have fractions instead of whole numbers. Secondly, today we're going to look at a second method we could maybe use when fractions are involved, where we could use the least common multiple, something we already need to know to add in order when we're trying to add with the same denominator. Least common multiple helps us there. It's also going to help us today with a second method that could help you eliminate fractions by multiplying every term in the equation by the least common multiple. So we'll get there in a bit. First guided problem today. I would encourage you to pause this video and work with your neighbor or your partner. Your first job together should be to explain your method for multiplying a fraction with an integer. That's a whole number that could be positive or negative. And then your job together after you explain how you multiply fractions with integers is to take both of these factored form expressions and use the distributive property to write them into expanded form. So pause the video, talk with your neighbor through part one where you explain how you multiply, and then actually multiply out both of these factored form expressions. Welcome back. I'm going to full screen my whiteboard. So hopefully we understand to take an expression that's in factored form. 15a, a variable term, and -6 cannot be combined, but we factored out the term 1/3 from both of them. So we could distribute that back in. We could multiply 1/3, the fraction, with each one of these terms. Multiplying by a fraction, hopefully you all noted something along when I multiply a fraction with an integer, I multiply by the numerator, that's the number in the top of the fraction, and then divide by the denominator. So that's all a fraction really says, top divided by a bottom, numerator divided by denominator. So I would go ahead and multiply by the top number, the numerator, and then divide by the denominator, the bottom number. Whenever we multiply by a fraction that has 1 in the numerator, timesing by 1 or multiplying by 1 doesn't change anything. So we're really just dividing by whatever the denominator is. In this case, both terms get divided by 3. 15a divided by 3 leaves us with 5a. And a -6 divided by a +3 produces a -2 for the quotient. 5a and -2, they are not like terms. They can't be combined. This is just our expression in expanded form. This was our expression in factored form. They're equivalent to each other. A little more complicated when the numerator has something other than 1 here, -2/5 times 20. And -2/5 also gets multiplied by the variable term -10b. That means we're going to multiply by the numerator, divide by the denominator. I actually think it's a little easier. 20 divided by 5 is 4. 4 times 2 is 8, so we get -8. 10 divided by 5 would be 2. 2 multiplied with 2 would be 4. And a negative times a negative is a positive, so we get a +4b. Could have done 20 times 2, which is 40. 40 divided by 5 is 8. 10 times 2 is 20. 20 divided by 5 is 4. Either way, we get -8 plus 4b. If you or your neighbor have questions, definitely put this on Classroom Q. Ask some questions from me or Miss Stewart so we can make sense of what's going on with multiplying with fractions. I think most of you are good there. Part 2, again, you're going to pause the video now. You're going to explain how you can divide by a fraction. And you're going to see that's really the key to solving equations when the coefficient is a fraction. Explain that a little more. We see here for these equations we're going to have to solve for each one of them, the coefficient, the number that's multiplied with the variable, is a fraction instead of a whole number. We know the opposite of multiplying is dividing, so how do we divide by fractions? It's going to be the key to solving equations like this. Pause the video, discuss with your partner, write in an explanation, and then solve each of these equations and provide an image of your work. All right, welcome back. The big key when we talk about dividing by a fraction, this is a fancy word, reciprocal, but all it means is flip the fraction effectively. The reciprocal of 1/2 is 2/1. The reciprocal of 3/2 is 2/3. Reciprocals are key because when we divide by a fraction, we just really multiply by the reciprocal. That's what dividing by a fraction really means. This has to do, again, dividing and multiplying are opposites of each other. So if we just divide by a fraction, that means flip the fraction upside down and then multiply. What does that look like in practice here? So if I have 1/2 times m equals 8, and I want to get rid of the 1/2, the coefficient, the opposite of multiplying by a half is to divide by 1/2. But dividing by a fraction really just means to multiply by the reciprocal. So in red here, for reciprocal, I'm going to put multiply by 2/1. Because if I multiply 1/2 by its reciprocal, 2/1, the definition of a reciprocal is when they multiply together, they just make 1, or in this case, 1m. Anything I do to the left side, I need to do to the right side. So again, by multiplying by the reciprocal, we can see how that's the inverse of multiplying by a fraction, is just to flip it upside down and multiply by its reciprocal. 8 times 2 gives us 16. So in this case, we know m was 16. You and your neighbor, if you were stuck, should now understand, hopefully discussing together before I'm getting here. What do I have to do? 3/2 times n equals -6. If I don't want that 3/2 there, the opposite of multiplying by 3/2 is to multiply by the reciprocal, 2/3. Same thing over here, multiply by 2/3, because this will leave us with n in the left expression, or just 1n, which is what we wanted. And then on the right side, -6 times 2/3, because we have to do the same operation or the same transformation to both sides of the equation to keep it balanced. -6 times 2 is -12. -12 divided by 3 is -4. I'm actually going to ask that for the third example here, you and your neighbor should understand how to do this on your own. See me or Miss Stewart if you and your partner need help there. Long guided problems today, I know. Sorry about that, but part 3 now. Here we go. Explain the most important thing you need to see when combining like terms. Whenever we add or subtract, we can only add or subtract things that are like terms, so we'll just start calling addition and subtraction combining like terms. But if I have to combine like terms and fractions are involved, what's the most important thing when we have fractions involved and we're trying to add or subtract those fractions? After you explain that, solve the equation below, you're going to see the key is adding or subtracting variable terms that have fractions in them. Okay, welcome back. Hopefully you and your partner paused the video. You gave us an explanation about the key thing to adding when we have fractions involved. I'm going to actually just show you this second example for the interest of time. You're going to have to do the first example on your own. But the key when we add or subtract, when we combine like terms and fractions are involved, the key is to have a common denominator. In the first case, we have a common denominator that makes that equation a little simpler. I'll show you the example when we don't have a common denominator. If it's not there, least common multiple helps us find the common denominator, or really transform into the common denominator, because we're going to have to change one of the fractions into the same denominator as the other. So method 1, for 1/2 y minus 3 plus 1/4 y equals -9. I want to combine these two variable terms. I see positive 1/2 y, positive 1/4 y on the same side of the equation. So in order to combine these two variable terms, they have fractions. I can only combine or add up my fractions when they have a common denominator. 1/4, I see this is a larger number in the denominator than this one, so I'm going to try to say, can 1/2 change to something like 1/4? Yeah, if I multiply by 2, if I multiply the top and the bottom here by 2, times by 2, times by 2, this becomes 2/4y, equivalent, same value as 1/2, so I'm allowed to just change that part of the equation to something that's the same value. Minus 3 plus 1/4 y equals -9. Now at that point, we can combine 2/4 y with 1/4 y. That becomes 3/4 y minus 3 equals -9. And you're going to be on your own with your neighbor.